Can you hear me? Sanjana, Arav, and Harik.
Yes, sir.
Yeah,
Yes,
please.
sir.
Let's start. So last class, I think we were somewhere here. Just confirm, यहाँ तक आप कर चुके हो? अब तक right, last time. ये. कहाँ तक कर लिया था? Confirm please. ये कर चुके हो? Amines and all is done.
Yes.
ये metamers complete हो गया था पूरा? Have you written acid derivative?
Yes, sir.
We did those questions last week.
So this is done.
No, before that. Before
So
that.
this is done.
This is done. एक बार कैमरा ऑन कर लो सारा प्लीज तभी शुरू हो पाएगी क्लास ऐसे कैसे शुरू करेंगे आ रही है You went to school Arav today
Yes, sir.
okay shall we start so I think somewhere here we were confirm कर दो एक बार what is metamer metamer is around a functional group which is having two valency we are jumbling numbers right left and right we are jumbling numbers so let's say you have oxygen so here and here we are jumbling numbers or NH we are jumbling number let's say 2 carbon here 1 here and 3 here right this is how metamers work out right this is how metamers work right now coming to next part if it is cases of tautomers so next right on the tautomers इसको वीडियो को ऊपर कर लीजिए what is tautomer chain position functional and metamer चार हो चुके these four you know okay now coming to the next part that is called tautomers what is tautomers anybody write one line for it movement of H plus between different structures in equilibrium with each other okay basically H plus move करेगा different structures में in equilibrium with each other and these structures are in equilibrium with each other so that H plus movement from one place to other place is known as tautomerization or tautomer formation fine
So could you repeat movement of H plus?
movement of H plus between different structures in equilibrium with each other. Just see this example. HCl becoming HNC. H यहाँ पे join था, अभी इधर पे join था. N से join. Okay. So and these structures are in equilibrium with each other. That is called tautomerization, or this is called tautomers. Now there can be two type of tautomers. One is called dyad. Okay. Like A is in equilibrium with B. So structure A is tautomer of structure B. That way. So there are two type of systems that exist. One is called dyad. Dyad. D-I-A-D, not dad. D-I-A-D. Not dad, right? D-I-A-D. Another is triad. Dyad means two. Triad means three. When hydrogen jumps from position 1 to position 2, that is called dyad system. 1 2 था, ये 2 पे join हो गया hydrogen. That's called dyad system. What is triad system? When it jumps from 1 to 3, first position से third position पे जाएगा. Then it is called triad system. Okay. Now note down some examples. Under dyad system, write down example of HCl and HNC. Under dyad system, write down example of HCl and HNC. Under triad system, write down example of Keto-Enol, nitro-acynitro, amide, iminol, imine, and amine. We can write more. Nitroso-oxime, nitroso-oxime,
So, with nitro, which one is it?
Yes, sir.
So, with nitro, it's which group?
Nitro.
Yeah, over here,
And
below keto.
and we'll talk about all the groups, don't worry. I'm just giving you names first, right? We'll talk about everything in detail. Do not worry. First, you just write down. These are different cases. Many more cases can be coming. So it can be even more bigger list. So I'm giving some names first. That when you get this kind of system, what do we call it? Tautomers. They are tautomers of each other. ठीक है? कौन कौन से हुए? कीटो, इनॉल, नाइट्रो, एसाइनाइट्रो, अमाइड, इमीनॉल, इमीन, एनामीन, नाइट्रोसो एंड ऑक्साइड. सिंपल है. अब चलिए एक तरफ से देखते हैं. जैसे फॉर एग्जाम्पल आपने लिखा, मैं एक बार फ्लैश ही बता देता हूँ. Let's take one page here. That will be. So, for instance, what is ketone?
Oxide, no. Oh, oxide.
Let's say you write ketone, CH3. C double bond with CH3. अभी आपने iPad पढ़ लिया, आपको आइडिया ketone क्या होता है. What is the name of this ketone? Niharika. What is the iPad name of this ketone? बताइए. What is iPad ketone?
Propanol.
It's a propanone. 3 members, 3 carbon ketone. Propanone. Do we need to call propane 2 on? Not necessarily, right? Propanone it is. Okay. Now do one thing. You please mark hydrogen of this carbon, which is connected here. Let's go to this carbon. And let's say write 1 here. सभी लोग ऐसे करेंगे. Okay. 1. This is 2 and this is 3. Now just observe, what is your functional group? C double bond O. What are we doing? On C double bond O, we are going to alpha position. There is a carbon. On this, there is a hydrogen. And this hydrogen, which is given here, is position number 1 with respect to 3rd position of oxygen. Can you observe this? Just observe this carefully. Very important thing. Now see another compound. थोड़ा ध्यान से समझना थोड़ा, क्योंकि यहीं पे सारी चीजें समझ में आनी है आपको, right?
Sir, could you repeat?
Just can you understand these positions 1 to 3?
Yeah.
So just observe that. Now draw the other compound. Let's say draw this compound. Which compound is this? CONH2 is called? Sham? Amide. CONH2 is called amide. What is the name of this compound? IUPAC name of this compound? It is 2 carbons amide. It is called ethanamide. Please write down. Ethanamide. Very good. अब देखो फिर से मैं वही काम कर रहा हूँ. 1, 2, 3. Just observe. Do you find repetition? What is the repetition? C double bond O. Next attachment is nitrogen. That time it was carbon. On that I'm marking one hydrogen. Can you see something same happening in both the cases? Keep observing. I'm keeping these 2 structures here. So we'll do everything at one go. एक shot में सारे खत्म कर देंगे. ठीक है? Next structure on your screen. Next structure on your screen. Please write. Which one? Which one? This one?
Yeah.
No. Amine is if there's no C double bond. Had it been CH2, then it is amine. This is C or H to the group, right? You consider. Now please draw this structure, which I have drawn. थोड़ा साइड में सो ड्रॉ करके अपने इसको यूज नहीं करेंगे बिकॉज मैंने इसका दूसरा काउंटर पार्ट बना दिया लेट मी ड्रॉ द फर्स्ट काउंटर पार्ट draw this structure now in this structure with respect to let's say I'm marking this position so this
So
is
what happened to the previous structure?
previous just keep it side I'll talk about it later. Can you observe 1, 2, 3 on the similar pattern? So this pattern you observe 2, 3 has some double bond. One is something which is carrying hydrogen. Check out. First one, 2, 3 is a double bond. One is something which is carrying hydrogen. 2, 3 is a double bond. One is carrying a hydrogen. 2, 3 is a double bond. One is carrying hydrogen. Right? Let's go to the next structure. Now this compound is what? This is called nitroso. This group is called nitroso. So if you say this compound, NO, nitroso is there and this is 2 carbons, right? So we can say nitroso ethane kind of structure. So I'm just writing word nitroso because मेरे काम का nitroso word है. Okay, it's a nitroso compound. Now why we are writing these things? The reason is I've given you a list of members. Just observe this list once again quickly. So you had a list of members which are all written here. So I'm trying to show you this, and this, right? All these structures I'm trying to show you. Now coming to the next, nitro and imine I'll draw. Just see. Next structure. This is the nitro group. Nitromethane we can say. It's a nitromethane, right? So one carbon is there. So name is you can say nitromethane. The previous one is nitroso ethane. If you want to write diagram. चलो अब इसमें देखो ध्यान से फिर से वही काम करते This is your hydrogen and this observation you have to keep it very strong. If you want to understand tautomers, you should start observing these patterns in different structures. So this is the structure. Next example. So nitrosomethane हो गया आपका, nitromethane हो गया, nitrosoethane हो गया, ethanamide हो गया. अभी एक और कौन सा केस बचा? One case is pending. चेक करें लिस्ट में बताइए. हाँ, amide हो गया ना? Imine. IMINE. Not imide. Imine and amine. IMINE and amine. ENAMINE. So imine ड्रॉ करते हैं. देखो imine कैसा देखता है. What is amine? Amine is CH2NH2. What is imine? CH double bond NH. Okay, this is imine. This is imine. Fine. Okay. Now look at the structure. In this structure, again, we find the same thing common. This is hydrogen. This is position number 1, position number 2, and position number 3. कुछ समझ में आ रहा है?
So
Again, what I'm trying to give you as a pattern, please observe in all of them. Even in this structure, this is imine. Which imine is this? It is imine with 2 carbons, right? So you can say it is imine of ethane. So we can say ethanamine. Okay. Ethyl imine. Imine. It's an imine system. What is common among all five of them?
So I have
Observe
a
the pattern.
doubt.
Yeah. Yes, sir.
So in
First,
the
you
last compound,
fog kind of thing I can see.
so in the last compound, why can't the N be one and or the H connected to the N be box like?
Good observation. चलो बच्चे ने बिल्कुल सही बात बोली है, इसको हम ऐसे करते हैं, कोई दिक्कत नहीं। और बताइए, अभी ठीक है? ये कह रहे इसको H लिखिए, ये कह रहा हूँ ना?
Yes, I'm asking why can't you do that? Like, why did you do the other way?
No. If you keep it H, this, are you getting the pattern? That's my question.
So I think so, yeah.
You're not getting pattern, no. So I'm trying to devise one pattern right now. That's why I have marked this. What is the pattern?
So but in ethanamide, you box the H connected to the N.
Forget about that. Where is H? Just observe the pattern. There is a double bond between 2, 3. Then there is a single bond between 1, 2. And there is a H on. Don't see the atoms. See the pattern, right? So pattern is same in all five of them. If I keep this as a pattern, can you observe there's a double bond between 2 and 3? There is a single bond between 1 and 2. And there is a hydrogen hanging on. Can you observe this common pattern all across? That is why I'm keeping this structure also aside. ये वाला मैंने ऐसे ना side में रख दिया था. इसको भी मिलाऊंगा तो confuse हो जाओगे. Can you observe this pattern? If this is clear, what you have to do next is you have to simply take these structures. I'll show with one. You'll do with other. This moves here. This moves here. Just see. So what is happening? Basically, oxygen goes and grabs hydrogen. If oxygen goes and grabs hydrogen, H is gone from that place and negative charge is formed on carbon. That will push and form a double bond. So the double bond placements are changed now. So what is going to happen because of this bond movement which I have shown? I will draw another structure which is CH3. C double bond will become single because you are picking hydrogen with the help of this electron. And this will become a double bond and this will be CH3. Niharika, is it clear? Is it fine? So that double bond forms here and that double bond becomes single. Can you observe? Because carbon cannot hold 5 bonds. If you look at this structure carefully, Sanjana, what is this group? Double bond. What do we call double bond? Nalpack?
The ene.
Very good. This is E. Okay. And what is OH called? All. Alcohol. Hence, this compound is called enol. What was this compound? It was keto. Okay. So what is this conversion called? Keto to enol transformation. This is called keto to enol transformation. कर लोगे? अब आप आ जाओ नेक्स्ट सिनेरियो. नेक्स्ट केसेस एक बार खुद आप ड्रॉ करिए. सेम लॉजिक से क्या कंपाउंड बनाते हैं. जस्ट टेक योर टाइम. Pass the laptop. Share one file to Tarun. Thank you so much. Please complete this quickly. Yes, can you please? Thank you so much. So everyone, we understand what we are doing in the first step. Now, can we repeat the same thing in the other cases and try to plot these structures? See, you will say this will move here, this will move here. Now, Akshay has asked a question here. Sir, why are you taking 1, 2, 3 from the nitrogen? Why not with carbon? ये भी तो H हो सकता था, ये भी 1, 2 हो सकता था. Okay, that's a valid question, but remember, if it is nitrogen, it is more electronegative than carbon. So I'll pick hydrogen from nitrogen first if that is the option. In the previous case, there was no option. So I picked from carbon's hydrogen on. Okay. Very good. Good. What will it form? ये बन जाएगा CH3 COH double bond NH. What is C double bond NH group called? बताइए. C double bond NH आज ही क्या है? नीचे क्या है? C double bond NH क्या होता है? Imine. Okay. What is this called? Imine. What is this OH called? All. तो ये क्या बन गया? Iminol बन गया. आ गया. And what was starting point? Amide. So amide became iminol. Easy. Any issues with this? RO is it clear now? Next case पे चलो. Next case पे क्या करेंगे? 1, 2, 3 same bond movement. क्या करना होता है? इसको इधर. What will I get? I'll get CH3. Then CH double bond N single bond OH. Now what is this group? देखो ये बना हुआ है right now. इसलिए मैं इसको साइड में रख दिया था. Can you recall this structure? देखो यही है ना same structure. So I kept it side because that was the second part, not the primary part. What is this called? This is called nitroso, and the group which is formed here, this functional group is known as oxime. CH double bond NOH. इसको बोलते हैं oxime. So nitroso, oxime. Nitroso becomes oxime. Is it clear? Next case, nitro. This moves here. We form a structure which is CH2 double bond and single bond OH coordinate or check condition. This is called nitro. This is called SI nitro. This is called SI nitro. This group NOH single bond coordinate or double bond C. It's called SI nitro. This functional group. Now next is ethyl imine. This is imine. अब क्या करोगे? ये ब्रेक किया इधर, ये ब्रेक किया इधर. Clear? Are you getting this or not? Or you can say, अगर प्रॉब्लम है तो इसको ऐसे करो. ये इधर. समझ में आया? Any issues? So what is the answer? CH2 double bond C single bond H single bond NH2. What is this group? Ene. What is this group? NH2 is called amine. So what is this whole thing called? Enamine. Enamine. And what is the starting point? Imine. So imine has become enamine in this process. Imine has become enamine. ये तो लोगों को पांचों नाम समझ में आ गया. At least you can recognize 5 names. Is it clear? Raise your hand if it is clear. Any doubts you can ask, please. Nitroso will go to oxime, imine will go to enamine, keto will go to enol, amide will go to iminol. Sorry, keto will go to enol, amide will go to iminol. Okay, nitroso will go to oxime, nitro will go to acylnitro, and imine will go to enamine. These are 5 situations you should be very much clear about it. All these systems you are marking 1, 2, 3, 1, 2, 3, and then movement, 1, 2, 3, then movement. Hence, all of them are known as triad system. ये सब क्या है? Triad. Remember diad and triad? What is diad? In diad, I have shown just one example, which was HC and HNC. Look at this piece. Only one example fits here. HC and HNC. Okay. Position 1, position 2, position 2, position 1. Just one example. Even you can't say CH3CN, CH3NC. This is not authorized to be called this diad system because that doesn't happen. You can't break CC bond. H can go. As an acid, it can go from one base to other base. That's a diad system. All other systems are triad systems. Where is this double bond? one bond you are breaking, that's how you are connecting to hydrogen. There are two electrons. Now see, this is oxygen. This electron being at oxygen, this electron given to hydrogen. Then only H is bonded. No? And H is losing its electron here, which is given to form a double bond. So, observation, if you keep very clean and clear on this, the basic observation is all 2-3 members were having double bond initially, and now after this, check all 1-2 members are having double bond. Check करके देखो एक बार जब ये 1 था, ये 2 था, ये 3 था. 1, 2, 3. Please check your 1, 2, 3. 1, 2, 3. This was the 1, 2, 3. 1, 2, 3. And the last one, 1, 2, and 3. बहुत simple सी बात हो गई. Double bond will go from 2, 3 to 1, 2, and hydrogen will go from 1 to 3. Easy. अब तो figure out कर सकते हो. This is called tautomerization, and this isomerization is in or under structural isomers. This is under structural isomers. Okay. ठीक है. Any problems with this discussion? Any issues? Now coming back to the discussion again. So we are back here. I've explained you all cases here. You understand the meaning of this tautomerization? Okay. Now, write down few points. H plus will move from 1 to 3. Write down point wise quickly. H plus will move from 1 to 3. There will be conjugation. Conjugation is in negative single double wala pattern. 1 to 3 alternate position double bond. You will use this symbol of equilibrium. You will use the symbol of equilibrium. Earlier, 2, 3 was having double bond, now 1, 2 will have double bond, or vice versa. 1, 2 will become 2, 3. See, if nitroso's tautomer is oxime, then oxime's tautomer is nitroso. If nitro's tautomer is SiNitro, then SiNitro's tautomer is nitro. If enol's tautomer is keto, then keto's tautomer is enol. So it's either way. It's not like one way. It's either way. So just pay attention to the second scenario also, where 1, 2 has double bond and 2, 3 will be single bond, and then later 2, 3 is becoming double bond. So reverse भी आपको आना चाहिए. कर लोगे? All right. Remove H plus. Never remove H plus from sp2 hybridized carbon. ये लिख लेना, बहुत important point. Never remove H plus from sp2 hybridized carbon. So अगर मैं ऐसा स्ट्रक्चर दे दूं आपको कि ये स्ट्रक्चर है, अभी ये H को निकालना बहुत मुश्किल होगा, because that's not double bond. These H are difficult to be removed. So never remove H plus from a double bond. You can remove from a single bond, not from double bond. ठीक है, next. ये कर दिया आपने. Now, let's
Can you
see
show
some
that
ideas.
once again?
Yeah. Please go down.
Yes.
Done. Now let's see some questions on this. Right now. CH3, CHO. CH3, CHO. Draw this structure. The structures are visible to you. I have to draw a lot of structures, that's why I'm drawing it smaller on.
So are those always like the oxygen atoms connected to the ring, like
Which one?
over here, this entire thing?
So he asked if oxygen connected to the ring. It's a double bond.
Oh, okay.
Okay, next set of examples. So 3 to 5, 5, 5, 10, 5, 15. What you have to do is you have to draw tautomerize isomers or tautomers basically. And in some cases, if it is not possible, you can say not possible. You get the question? You have to draw tautomers, but in some cases, if it is not possible, you can say not possible. We can't do. Carry on. Keep on solving. Call. Take your time. कर रहे सॉल्व आप लोग?
Yes, sir.
When you have? Will listen to that. This is a good cross. Check your notes, last notes. Yes, Sapit. आज फिजिक्स है ना? हाँ आ जाओ। अरे सही हो जाएगी तबीयत, आ जाओ। ठीक है, आ जाओ। हाँ आप करा देंगे, आ जाओ। आशन से इधर ही है, आ जाओ। ठीक है, ओके ओके। Okay, let's see few cases. Case number 1, for instance. So case number 1, CH3CHO. You will say this is H here. This will move. This will go here. And the structure which you can form is CH2 double bond C OHH. कितना will draw कर लिया? Raise your hand if it is done. First is done. Sanjana, Niharika, Arav. Any doubts in this? Okay. Question number 2. Will it give or not? Arav?
So no.
Why? H is here.
Oh
Right?
yeah.
This hydrogen. 1, 2, 3. What can it form? This moves here, this goes here, right?
Yeah.
So answer will be what?
Enol.
Enol. So this becomes single bond OH, this becomes double bond. Cyclohexenol, to be more precise. Here, this example. Now look at this position is blocked. You can take from this position, or you can take from this position also. Why? Because if this moves here, and this can take here, right? That's option 1. Or you can do it on the right hand side. This is more preferred option because it's in conjugation. Conjugation आपको पता है. Conjugation क्या होता है आपको पता है, right? So if it is not third position, check 5th position, check 7th position, check 9th position. And if conjugation is there, conjugation is like it can send you from one place to other place. Single, double, single, double, single, double, right? So that will translate directly to that place. Look at this example. These 2 hydrogens are there. Which one? This is correct, but that is better answer. This is not wrong, but that's a better answer. Okay. So in this case, this can move, this will move, and this will become OH. So what's the answer? The answer देखो ये बन जाएगा phenol. Aromatic structure होगी. So very stable structure now. So this can give. Don't do the mistake of taking H from this place, this place, this place, or this place. Don't do the mistake of taking H from these places. Don't do the mistake because there are double bonds. You can't remove H from that. You have to take from this position. Is it okay? Next example. What's the answer for this case? Sanjana, what's the answer?
So I didn't get it.
Okay. Will it give or not give? Will
Same.
not give. Will it
Same
give or
as
not
the-
give?
Same as the. Oh, no.
So just observe, on this place there's no hydrogen. You can't do anything out of it, right? This structure is not capable of giving you any tautomer. Is it clear? Because from where you can take H, that is having CH3. अभी कहाँ से करोगे आप? H लेके कहाँ जाओगे? Is it clear? So answer is no. So out of first 5 cases, 4 will show, last one will not show. Look at this example. Niharika, will it show or not show?
So it
एक
will
तो आप लोग
show.
अपना कैमरा पहले सही करो भाई. कोई छत दिखा रहा है, कोई पंखे दिखा रहा है, कोई दिखाई नहीं रहा है. कुछ तो एकदम बिल्कुल ऐसा
वैसा.
बिल्कुल आत्मा जैसा दिख रहा है मुझे. कोई आत्मा झांक रही है वहां से.
So the stand is lower, so.
No, I'm talking Arav.
Oh,
So
okay.
the
आरव जी एक बार ब्लर हटाइए प्लीज पहले आप तो.
yes.
मैं दिखे तो सही, आप सो रहे हो, जाग रहे हो, क्या कर रहे हो? ब्लर हटा दीजिए एक बार. अभी भी ब्लर है.
So I removed it.
Glare from
That
the.
just glare because of the light.
बंद कर दो ना फिर उसको.
So then my room will become
क्यों ऐसा
dark.
हेलो इफेक्ट चाहिए?
So it'll become dark then.
Okay. So are you getting these questions or not? Tell me first. हाँ पक्का? How about this question? Will it give or not give? चलो बताइए. आरव बताएंगे इस बार.
The 1 second.
We talked about conjugation. We talked about resonance. We talked about taking hydrogen from these things is not possible.
Yeah.
So what is the answer? Yes
So
or no?
no, no.
No. अच्छा कितने लोग इनको सपोर्ट करते हैं? Raise hand करो. If you say no, no वाले एक बार hand raise कर दे. Sham is supporting you. Only Sham. Sanjana, you're not supporting.
No, sir.
Why?
So because I think it can give hydrogen.
From which position?
So, I don't know.
अरे ये वाला hydrogen. See this hydrogen. Now, see the conjugation power. This can go here. this here, this double bond here, this here, and this will get H. Okay, so this can grab from one corner to other corner. This is possible, and the structure will realign as this. See, पूरा aromatic structure बन गया. ऊपर वाला भी, and the lower one also. So definitely it is doable thing. No, both the rings are becoming aromatic for me in this case. Hence, easily this H can be taken up by oxygen in given solution. Is it okay? So this is aromatic. This is aromatic. Earlier it was not. So now this is possible. Next example. CONH2 is amide. Amide. Niharika. Answer. Will it show or not show?
I think it won't show.
कैसे? कहाँ से show करेगा?
So I'm not fully sure.
This place. Okay. 1, 2, 3. Check your notes. Okay.
Oh, okay. Okay, yeah, got it.
What's the answer? Ring COH double bond NH. What is the compound form? Aminol. कितने लोगों ने बना लिया था? Amide से aminol. Raise your hand. This way. Complete remaining. Anyone who has done all? Need to finish. So how do you finish? चलिए करिए आगे के केसेस करिए. So this is what oxime. Nitroso. This is a 2-3 position. And this H is more acidic. O is a connected H. This H is carbon connected H. So if you try to, this one, this will move here. So H यहाँ पे. That will come easily. शाम हो रहे हैं. Any problem with this? No? So shall it be 1, 2, 3? 1, 2, 3 or further? Why not another? Excuse me. Why not other way around? So, which of H is more acidic? Carbon's H or oxygen's H? Which you can take easily. So do it the other way. How many of you have completed all of them? Raise your hand. Okay, let's see the next three first quickly. What is this compound? It is called enamine. It is ene and it is amine. So what is its counterpart? How can you draw its counterpart? Its counterpart, tautomerized answer would be, okay, imine. Basically this grabbing H and this getting, right? So what's the answer? Structure will be this. यहाँ पे H भेज दो, यहाँ पे double bond NH. कितने लोगों ने draw किया? Raise your hand. Enamine becoming imine. You don't need to show the H. You don't need to show. Ah, that's okay, that's okay. We draw this. Next example is reverse of it. It is imine. Now I can show enamine of it. How will you show enamine of it? You'll say, this is carbon. इधर पे एक H लगा है. This is 1, 2, 3 for me. Okay. This moves here. This goes here. I'll get the same structure. कर लेंगे. So same question I asked two times. Reverse and the other way around. Next is nitro. Nitro की alpha position. So always remember nitro group. This is alpha carbon. And on this, whatever hydrogen is there, you can mark it. Right? This is called alpha carbon. So 1, 2, 3. Easy. That's why it is 1, 2, 3. So what are you going to do? This will move here. This will go and grab H. What will it become? It will become a ring. Double bond N. Single bond OH. Accordingly. ऐसे nitro. कर पा रहा? How many of you have understood these cases? Raise your hand. Sanjana, Niharika, and Arab. How about you? Is it clear?
Yes, sir.
Problems, please ask. What is next functional group? Niharika. What is this functional group? This one.
Sir, amine.
Huh?
Amines. Amines.
It's not amines. C double bond NOH. Check your notes. आज ही किया आपने. Which functional group is this? Huh? Is it imidol or is it oxime?
Oh, okay.
Oxime. C double bond NOH is called oxime. What is oxime's counterpart? Nitroso. Nitroso. So it will be like this. CH3, H, one more H, single bond and double bond. Can you draw this? Have you drawn the same? Nitroso. Now the next example. It is nitroso. Nitroso's counterpart? Oxime. Oxime बन गया. Next example. This is hydrogen. You can take this hydrogen, send it here. It will become phenol. Aromatic structure. Next example. It is urea. The compound which is shown is urea. NH2CONH2 is called urea. Now same thing. 1, 2, and 3. This goes here. This takes H. Answer is NH2COH double bond NH2. Okay. This is urea. You can automate this again. What do you want to do after that? Like 1. So we'll go back to again same position. No? Yeah, it will be the same structure again. You go back to urea again. Next one, NH2CHO. Okay, same thing. Amide. Amide का क्या बनाओगे? इमिनॉल. ये इमिनॉल है. ध्यान से देखो, इमिनॉल और ऑक्साइड में कंफ्यूजन हो सकती है आपको. Confusion is very simple to be removed. This is iminol. Imine is this group, C double bond NH. Oxime is C double bond NOH. That is oxime. Okay, clear हो गया? कितने लोगों को सारे के समझ में आ रहा है? पक्का कर लोगे? ऑनलाइन पीपल, आरव,
Yes, sir.
हो पाएंगे सारे? चलो नेक्स्ट क्वेश्चंस आप ऑनलाइन वाले बताएंगे, इसका आंसर बताइए, विल इट शो और नॉट शो? एनी वन ऑफ यू ऑनलाइन?
Sir, it won't show.
Answer is won't show because there's no H, there's nothing.
Yeah.
Next example, nitroso, will it show or not show?
No.
Reason same problem, there is no hydrogen.
Yeah.
Next one, Sanjana and Niharika will answer this time. This one, will it show or not show? This is C double bond NH, imine system. This is alpha carbon. Will it show or not show?
So it won't show.
Won't show. Reason there's no hydrogen here, right? Had it been hydrogen, it would have shown. There's no hydrogen which you can take, so there's nothing we can do about it. Next one, this is a nitroso, but on this position there's no hydrogen. It won't show. Last one, this is amide. There is no hydrogen here, there is no hydrogen here, nowhere hydrogen. This also cannot show. Aage. So tautomers, I hope you understand how to draw tautomers. Is it clear? Take a break of 10 minutes. We resume at 3:17 sharp. 3:70. Okay. बहुत लेट हो गए.
So this time we were check.
Yeah. Yeah, very sorry for being late.
So next time can we be like,
Huh? No, no, no. Clear? Any doubt on this? Any questions? चलिए आगे बढ़ते हैं. So ये हो चुका है आपका, ये हो गया, ये सब ऐसे केस भी कर लोगे, राइट? सी longer chain, take from the extreme corner position, then make everything element. Look at this kind of structure also. Take from the extreme position and then movement and double bond. कर सकते हो? Just draw the structure. Or if it is clear, fine. ठीक है? Can this compound give tautomer? No. Reason? Hydrogen cannot be broken from double. ठीक है? तो आपको amide imine समझ में आ गया? Sorry, amide iminol समझ में आ गया?
yes.
Okay. Check this. Please draw this compound. Try to draw its tautomerized answer.
So if it's given there.
Yeah. Please draw. How will it look like? After the movement, what will be the next thing form? And I hope all of you are writing test also. ठीक है, अपना स्कूल का तो करते ही रहते हो, but please keep writing test. At least 5 to 6. Those tests are like assignments only. If you are not comfortable with the topic which we are giving you, you can write any other topic also, but keep writing. You don't stop. कितने लोग वीक में 2-3 टेस्ट लिखते हैं? Raise your hand. From the portal, you write 2-3 tests at least. Okay, good. Everyone, please make sure that you write. Done. This is the compound that you can form. Check. CONH. कर लोगे? This reaction will come later in 12th standard also, so just remember. Okay. Nitro we have seen. Nitroso-oxime we have seen. We understood all these examples. No need to write down. Amine, enamine we understand. Correct? And almost all these questions, more than that I have done with you. Now, next heading. Structural isomers are over. Chain, position, functional, meta, and tauto. These are 5. All 5 are done. Coming to the next side of story, stereoisomers. Write down stereoisomers. And in stereoisomers, write down the heading geometrical isomers. Geometrical. Geometrical. Geometry. What is meaning of geometrical isomers? क्या मतलब होता है? Different orientation. दिखने में अलग हो रहा है, right? Okay. Same molecular formula, same structural formula, but different orientation. Different orientation. जैसे. Now just see this example. First compound is 1,2-dichloroethene. The other one is also 1,2-dichloroethene. But first compound, both the chlorines are same side of double bond. In the next example, both the chlorines are on opposite side of double bond. What do we call same side things? Cis. Okay, the name is cis. When both the chlorines are on same side, we call it cis. And when they are opposite side, we call it trans.
So does it matter where the chlorines?
Yeah, see this structure and this structure are not same. Okay, geometrically they are different structures, right? But if you don't go into the depth of it, both of them have name 1,2-dichloroethene. If I mark cis and trans, can I say these are two different possibilities? Now, double bond is a system which fixes the whole thing in the given plane. It is not freely rotating or the bonds cannot go anywhere, right? Randomly. So, if you say double bond means there's a pi bond and there's a sigma bond, right? In this case, it's like frozen kind of thing. Now, if a chlorine is here and the other chlorine on the other side, then definitely it will be a different structure altogether. Okay? Please draw this example. So when you have a double bond between carbon and you have two chlorines same side or two chlorines opposite side, That structure is known as cis-1,2-dichloroethene and trans-1,2-dichloroethene. कर लेंगे. Check the next example. Look at third compound. Can it show geometrical isomer?
No.
This is 1,1-dichloroethene. अब इसमें geometrically क्या different हो सकता है? Both the chlorines are one side, both the H are other side. So can we have any geometrically possible option with this? Answer is no. So what is the understanding with these examples? 1, 2 are stereo. 1, 3 are structural. They are structural isomers. To be more precise, can I call them positional isomer or position isomer? Because they are 1,2-dichloro and 1,1-dichloro. Ethene is common in both the cases. And 2, 3 is also structural isomer. कर लो, कोई problem? This is stereoisomers. The orientation is different. So stereoisomers. Next point. Under geometrical, there are three categories that will come across. One is cis-trans, so there is ZE, third is sin-anti. Note down. Cis-trans, ZE, and sin-anti. Three systems will be there. First case, will this compound show geometrical isomer? So the rule is, if you have C double bond C and the groups here are different, then they can show geometrical isomer.
Sir, can you go up?
Geometrically different possibilities are there, right? If let's say this side is both A, can they show geometrical isomer? No, because even if it is AB, it doesn't make any sense. You can't draw any other structure, right? So this compound can show geometrical isomer. If you have this kind of situation, you can't get geometrical isomer because this and this are same actually. It's like flipping upside down. See the structure? इसको पलट दो, ऊपर से ऐसे roll कर दो, roll over. You'll get this structure. This is the same, right? There's no difference. Condition of getting geometrical isomers on C double bond C. This is the condition. Please note down. Okay. Take your time. If there is a single bond, can it show geometrical isomer? No, because single bond is free for rotation. It can move. Okay, it can move freely. So we can't have any fixed setup, right? In that case. Triple bond also cannot give. Now summary. Number one, there should be a double bond. Group on same carbon should be different. Rule number two. It should exist as a separate geometrical identity. Rule number three that you keep in mind. Please write down these three rules. To get geometrical isomers, number one, it should be having a double bond. The groups on same carbon should be different. It should exist as a separate geometrical identity. Separate geometrical identity. Separate geometrical identity. All right. कर लेंगे quickly these examples. See, HFClBr. Can it show geometrical isomers? Oh, yes, it can. Why not? Okay, Cl and H are same side. Next time you can say Br is here, Cl is here. So it's other way. Correct? Okay. Can this compound show geometrical isomer? No, because H is same. Can this compound show geometrical isomer? Yes, because Br, I different, Cl F different. Please write down. फटाफट एग्जाम्पल नोट कर लो ताकि आपको बाद में रिवाइज करना हो तो you should have examples. Check fourth and fifth. FH, can it show? Yes. HH same side cis, other way it's trans. Next one, BRCl, IH. BR, II. Can it show? Answer is no. Go to a carbon, check both the groups must be different. If yes, then we can say they can show geometrical possibilities or structures. ठीक है? Okay. So cis and trans, you understand? If it is HH, if it is this kind of structure, opposite, then trans. Any problem? कितने लोगों को समझ में आएगा? Cis trans ढूंढ लोगे? अच्छा बताओ, इसमें cis trans क्या है? How will you do cis trans in this? Can you do cis trans in this? Because the groups are not common. Okay. Can you do cis trans in this if I put Cl? These two CLs are opposite. At least you have something to mark about, right? Okay. But for all these cases, we use a different nomenclature, which is called Z and E. Okay. Now, what is Z and E? This is under a rule called SIP rule. Right now, this word SIP, not SIP, systematic investment. SIP, CIP. What is full form of CIP? Akshay. C for can. C is can, CHN. Ingol. I for Ingol. P for prologue. Can, Ingol, prologue, or SIP rule. Now, this SIP rule is basically giving you Z and E kind of naming. Now, write down the rules for this. SIP rule होता कैसे? क्या क्या चीजें इसमें होती? Point number 1. Priority of atomic number. Okay. So you'll see atomic number, which is also called Z, as the first priority. You see which is having more Z, you mark that number 1. So for instance, if you are given on carbon, fluorine, bromine, iodine. So go to a carbon, you have two members, fluorine and fluorine. Which of them have higher atomic number? Niharika. Fluorine or fluorine?
Sorry, sir.
Which is having higher atomic number out of these two?
Fluorine.
Fluorine. Now go on other side, left side. Bromine and iodine, which is higher? Fluorine, bromine, iodine. No sequence.
Iodine. Sorry.
No problem. Now, if both high priority on same side, high priority on same side, then we call it Z. So this structure is a Z structure. Okay. The rest you write the name. As in fluoro, bromo, iodine. How do you write the name? You write the name, but this is Z form. Had it been other way around, let's say it had been C double bond C, Cl, F, Br, I, then it is E type. Okay. When high priorities are on opposite side, that is E. Please write down this example. High priority same side Z, high priority opposite side E. कर लोगे cases पे. So we will practice questions on this also. Next part. If you want to check geometrical isomers in a cyclic or ring structure, note down the rule for it. Minimum 2 carbon with both the groups are different. Minimum 2 carbons with both the groups are different should be present. For example, look at this compound. The rule says minimum 2 carbons with both the groups different. Look at this compound. So I have these 2 carbons, right? See here, HBr is different, HI is different. HCl is also different. We require minimum 2. You have 3. That's okay. At least 2. Look at the next example. HBr, HCl, HI. All 3 are different. Excellent. We can get more isomers. CLH, HBr, HI. इसी को मैंने reverse तरीके से draw कर दिया. Now look at this case. HBr, HCl, HI. 3 are different on a ring. Good enough. We can get more isomers. So what you have to do? Let's say you have Cl, Br and I. See the first example. HI, HI, HBr, HBr, HCl, ClH. Geometrically different होगा. On this top, all three are H. On this top, HClH. Geometrically they are different. Structurally they are same. Structural wise they are same. Geometry wise they are different. Are you understanding? Look at this example. HI, 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 HCl, HCl. Look at the last one. HBr and BRH. So basically playing around with the structures in a certain manner and getting different permutation and combinations, right? For example, here Cl and Br are same side. Here Cl and Br are opposite side. Here Cl and Br are opposite side and I is on the side of chlorine. Here Cl and Br are opposite side. I is in the side of I is opposite of chlorine. Can you see? Their structures are different. So you start drawing different patterns in that case. And they're all geometrical patterns which are giving you geometrical isomers. Easy. So if you're given a ring, how do you decide whether it will show geometrical possibilities or not? Find out two carbons, minimum two carbons with different groups. Minimum two carbons with different groups. Very good. Can this compound show? FCl different, HH same. FH different, HH same. HI different, FBr different. बहुत सारे different है, हो गया. मेरे को इतना check ही नहीं करना. But अगर ऐसा question आ जाए, HH, Cl, Cl, and then HBr, then
Yes.
answer is no. HH, Cl, Cl, HBr. Only one position is different. This is same, this is same. Sharp.
Minimum.
Okay, minimum two is needed. दो से ज्यादा कोई दिक्कत वाली बात कर लेंगे. चलिए, तो यहाँ तक आपको समझ में आया. इस पर थोड़ी सी मैं प्रैक्टिस कराता हूँ with questions. So let's do it. Answer this question. Which of the following compounds will exhibit cis-trans geometrical isomerism? Right? You will find a C double bond C structure, and that should have on every carbon two different groups. So these groups on one carbon, other carbon, they can match, but on the same carbon, that should be different groups. Okay? कर पाएंगे? Will exhibit. C कैसे दिखाएगा? 2 butanol है. हाँ, ये तो हो ही नहीं सकता.
Only D is there.
D कैसे दिखाएगा? ब्यूटेनॉल है.